All right, I'll get started. Good to see so many of you here. We are going to talk about JavaScript and Firebase game programming and how I used these tools to become a better dad. So, my name is Martin Omander, and I grew up in Sweden. I lived the last 17 years in Silicon Valley. I worked at 3 startups as a software engineer, and one of them went public. Woohoo! So my batting average is 1 out of 3. Then the last 10 years, after I got kids and a mortgage and things like that, startups weren't for me anymore. So I've been working at Google for the last 10 years in Mountain View at headquarters there. That's where I live as well. And my job is to support Google developer groups. So you may or may not know this, but this event, this DevFest, is put on by the Google developer group here in Washington, D.C. And that group runs this big DevFest every year, but then also monthly meetups. So if you are into modern web technologies, Android, Google Cloud Platform, other cloud technologies, you should check out the Google developer group in Washington, D.C., and go to their events. So this is a great job to support the Google developer groups in North America. I love it. And I might even be doing it even if I weren't paid. Don't tell my manager. This job, however, carries one disadvantage with it, and that's this. There's a lot of travel involved. Here, you see me, and in the seat behind me, my coworker Liz. We have been circling Dallas for 2 hours at this point, and ended up being diverted to Oklahoma City. And I don't know much about Oklahoma City, but I know one thing. It's very hard to find a good meal in Oklahoma City at 1 a.m. So when you're traveling too much, and then you want to have really good quality time with your family, with your kids when you're at home. So if you're a programmer like me, you automatically think, then I'll do a programming project with my kids. So I started doing one with my son, and I'm going to talk about here what we learned. So basically, if you take Firebase and you take JavaScript and you put them together, you get a better dad, that's me, and a happy son, and that's him playing the game right there. So we decided to build a game, partly because building games is fun, also because it's kind of hard to convince your 14-year-old son that you should build a business app together. Games are interesting and peculiar. There are high expectations on them. They need to be fast. You need to have good performance, smooth animations. They need to be shared. Multiple players are doing things in a complicated way, interactions in real time. And they need to be user-friendly, because if it's not easy to understand the game, players will not enjoy it. So lots of requirements on games. But what we noticed as we were working on this is that increasingly, regular business apps need to be fast, shared, and user-friendly as well. So I'm hoping by telling you what we discovered when we built this game, and sharing the lessons we learned, for you to learn those lessons vicariously, and also be able to use these lessons when building your software, whether it's games or business software. All right, so our use case is that this kind of looks like game night at our house, except we have maybe 10 or 15 people instead playing board games. My wife makes Swedish meatballs. We have that. It's great. We break out the board games afterwards. And it's great fun, and there are people of all ages. The drawback with board games, though, is that if you're 10 people around the table, you are actually active and moving your pieces 10% of the time. And 90% of the time you're sitting there waiting. But it turns out that everybody brings, even if we don't ask them, everybody brings a supercomputer to game night. They bring this. Everybody brings a phone. So we came to this idea, let's do a game that requires lots of interaction, physical interaction in the room, but where the moves are facilitated by the computer or tablet or your phone or a phone. So this was a use case. For our setting, we picked, the setting is that you are officers, your crew members on a spaceship command bridge. You have a captain, an engineer, sensor officer, operations officer, and so on. And you all play different roles. So the engineer produces power for the ship. The operations officer distributes the power among the systems on the ship, and so on. And you all have to work together. It's collaborative to complete missions. And missions could be like deliver cargo to the moon, or do asteroid prospecting, or shoot down an enemy ship. Okay, so that's the audience, the setting, and now it's time to start programming. So the way I've been taught to build systems, and the way that a lot of systems are being built today, you've probably seen this before, is this classic three-tier architecture. So everything in the pink boxes is stuff, it shows up pink there. Everything in the pink boxes is stuff that you would build. You would build code that runs on the client, you would build code that runs on the application server, your backend code, and you would have your schema and maybe even stored procedures in the database. So this is a well-understood architecture. The drawback is, though, that if you want to add a feature or fix a bug, very often you need to go in and mess with all three pink boxes, and in different programming languages as well, to add insult to injury. And when it's only me and my son building this in our off hours, we don't have time to set up big, complicated architectures and wire things together. We want to write code and build new features. So the new architecture that I'm seeing increasingly, I work with a lot of startups, and I hear their pitches. And I talk to venture capitalists about this as well, and they've seen that they see this new architecture that is increasingly replacing this. So I'd like to share what this new architecture is. And even if you're not in a startup, what startups are doing today is what the rest of us who work in regular companies will be doing tomorrow. So this is the new kind of architecture, a one-tier architecture. Or in venture capitalists sometimes calls this the no-stack architecture. Because, what stack are you on? Well, we're on Linux and MySQL and Python, for example. But this is sort of the no-stack, because you don't put all those pieces in. You just have your code, one pink box, that's your stuff. A solid JavaScript library provided by vendor, in this case, Google. And a backend service, in this case Firebase. So we used this architecture because we wanted one pink box, not three pink boxes. And there's a mobile equivalent to this one. If you build a native mobile app, it looks like this, but it's the same idea. What's really cool and really made us go for Firebase for this one, though, was that not only is this a one-tier architecture, but if you have multiple clients hooked up, and one of them sends data to the server, saves to the database, then all the other clients which are connected, they get updated with the new data. So these three clients end up sharing the same application state the whole time. And that got us excited, because while others might see interesting business apps here, me and my son, we thought, this is an excellent architecture for a game, for a multiplayer game. So this is not only a one-tier architecture. The way we choose to interpret it it's a real-time architecture. So let's just look at what those arrows are. I said that it's easy, it's just arrows, but let's actually look at the code behind these arrows. And we're talking JavaScript here because we built our game in JavaScript. So first up, to set up a database connection is super easy. You just create a new Firebase object and put your URL in there that you got from Firebase. And this could be a URL to the sort of root of your database or to some point inside your JSON tree if you want to just update a subsection of your JSON, of the database. To write is very simple. For example, let's say Martin, I got score 4,500, and we want to write it to a high score table, and we want to add a record saying Martin got 4,500 points. We would do something like this. We just push a new record, and here you see that we're pushing a piece of JSON in there. A very simple piece of JSON. We could push something more complicated that is nested and so on. Now comes the tricky part, and this is the part where I admit I struggled for a few days with this part of JavaScript. It took me a few days until I got into the zen of Firebase on this one. Because I'm used to, and many of you are used to, when you need to write data, I want to know, what users do I have in the database? Select star from the user table, and I do it on when I feel like it, and I decide. But in Firebase, someone else can update the data too, right? So instead of just issuing your read command, you do this instead. You say, if, in this case, child is added, if a new record is added to the high score table, then call this method, execute this callback. And you get a child snapshot, you get the data back as well, so you can update the UI. So this is, it's a different way of thinking about things. Took a couple of days for me to figure out, but once I've gone this way, it just feels very natural, and I can't imagine writing a game or any other app where data comes in from the outside any other way. All right, I think that's enough code for the moment. I think it's time to play the game. You want to play a game? Yeah, there we go. Yeah, okay, good. All right, so let's have a look here. Very good. The sound sounds so much better on these big speakers than on my teeny little laptop speakers that I've been playtesting with all this time. Okay, so here we have a list of all the games in progress. I will do this. We're going to pretend we're two players here, just so you see the thing in motion. One player over here, we're going to play a very simple, I'm going to play a very simple mission that we can't really fail at. Well, we'll see. This is a shakedown cruise mission. So on the left there, we have a pilot, and on the right, we have the sensor officer. So the sensor officer, maybe turn on there.
Navcom powering on.
What's going on there? Let's reload that page. Good.
Navcom powering on.
So we're turning on navigation computer. So now the pilot can see what's going on here. And now they have to collaborate, right? Because the navigation officer, the sensor officer, he sees where these points are. Oh dear. What's going on? Oh, okay. I forgot to turn on life support. This is usually the point where my son starts yelling at me, like, Dad, you need to... Okay, let's see if that helps. Okay, life support CO2 here is dropping a little bit. Okay, let's plot a course, pilot, plot a course to bearing 78 degrees. Okay, so we go over here as pilot, turn on the engines. Okay, good, we've come down a little in CO2 over here. We'll plot, so let's see, 78 degrees. Ooh, I like the sound from these speakers. Maybe something like this. Okay, so that we're on course here towards, I don't know if you see it, but there is one of our objectives we have to hit. Shoot. This gray thing is actually an asteroid field here. Let's see. Okay. We'll turn around. Okay, we'll just need to. Oh, I can't click this thing. Okay, what? We'll do this. Okay. Whew. Okay, so this is usually where the recriminations begin. So my son says, Dad, we had that. We would totally have succeeded in that mission. Why did you screw up there? And usually I forget to turn on the life support or fly into an asteroid field. And my son is very helpful. He tells me also, Dad, building a computer game and playing a computer game are two different skills. You have one of them. But we have a lot of fun. At least I have a lot of fun. My son gets very frustrated. We have a lot of fun. And it's a lot of interaction going on around the table, and we can play up to 5 people at the same time. So we learned a bunch of technology lessons when we built this. Things that worked. We built naive implementations at first, and then had to rethink what we were doing. And I'm going to show you 5 of those lessons. And there are 4 more that I actually have slides for, but we won't have time to go through here. If you want to come and geek out about game development and showing 60 frames per second and doing multiplayer games, or have questions about game development or Firebase, come outside. I'll be in the atrium out here, and I'll be happy to show you the other things or answer your questions. So the very first lesson was actually a very positive lesson. Syncing this game state across clients can be kind of hard. But here we see 2 clients, 2 players running one browser each. And what's going on here on the left-hand side is that the left-hand player created a new game, and it showed up in the table of games. So he clicks create game, he picks out, he wants a 3-player mission, he picks out the shakedown cruise mission, then he clicks OK. And boom, that new row in the table appears virtually instantaneously on both players' screens. And now they're running on the same computer, but they could be on the opposite sides of the world, and this would still work. So let's dive in, and I'll just show you. But this took a little bit of this was not easy for me to understand how this worked, and I had to tinker a bit with the code to really understand it. But what's going on behind the scenes is this. If you've ever built any kind of web application, you've built this. You have a user interface that's HTML, and you have your JavaScript variables and JavaScript code. And if the user does various things, clicks and drags and whatever in the user interface, then you move stuff into the JavaScript code. The JavaScript code does things, stores values. And the JavaScript code might also update the user interface. So there's a double-sided arrow between those 2. Many of us have built these. What's new here, though, is that then the JavaScript saves to Firebase. So this is the database in the cloud. And many of us have built these sorts of things, too, where we save. We make an AJAX request, for example, to save something or to read some data from a database somewhere. But the new stuff that comes in here is that now if player 1 saves, player 2 will automatically get this notification. And the JavaScript will be updated for player 2, and the HTML will be updated for player 2. Let's talk about the arrows in some detail. So many of you have used, has anybody here used Angular? The Angular framework? Yeah, 20%? Okay. React framework, about the same? Okay, cool. So there are a bunch of frameworks out there that people use to shuffle information between HTML and JavaScript. Here are some of them. Some people even write raw JavaScript. For this project, I wanted to learn Angular, so I picked Angular for that. So Angular, basically, you just say that this field in the HTML maps to this variable in JavaScript, and you say that once, and then that connection is set up. And if one is updated, the other one is updated automatically. And then the Firebase team has written some very cool libraries for the other arrow here, up to the server. So if you use raw JavaScript, you can just use the firebase.js library. If you use Angular, you would use the Angular Fire library. And if you use React, you would use React Fire, and so on. So because I used Angular, I ended up using Angular Fire up there to the client, up to the server. So let's look, see what the code actually looks like. We have, three-way data binding, right. Angular or React or all those, they provide two-way data binding otherwise. But here we actually have three ways, HTML, JavaScript, and the database. If one of those three changes, the other two change automatically. Magic! So here we have a table of all the games in progress. You saw this before. So we only have one item in the table so far. This is the ship called Santiago de Cuba, and it's on the mission. It's the shakedown cruise, and then we have some join buttons here. So let's look at what the code actually looks like here. And I'm using Angular. So on the HTML side, it's a standard, almost standard HTML table. The biggest difference here is that the second row there, you see it's a table row element, and then we use the ng repeat directive. So this is Angular speak for saying, go through the list of games and loop over that list and create one table row for each game in the games list. And for each one, in the first table cell, show game.shipName, the name of the ship. In the second, show game.mission.name, the mission name. And then show a join button, show a bunch of join buttons. So the HTML becomes pretty easy. Now the JavaScript, the job of the JavaScript here is to provide this games, this list of games. Unfortunately, thanks to the awesome Angular Fire library, I'm in awe of the people who wrote that. This is what it looks like in JavaScript. You create a database connection, and then you say scope.games, $scope, this is Angular speak for putting stuff in a scope that Angular can understand. And you're saying games equals Firebase array from this reference. And you're done. So this is what's needed to have an app that shows stuff in a table, and if things are deleted from the database, they automatically are deleted from the table. If they're added in the database, they automatically appear in the table. If they're modified in the database, they're automatically modified in this HTML table. I did not expect it to be this amount of code. So there was one more thing in the interface, though. There was a create game button. So in HTML, it looks like this. The only thing that's Angular specific here is that we have the ng click directive. So that is basically, in regular JavaScript, it's called onClick. In Angular, they call it ng click. And then in the JavaScript, we need to define the create game method. So this is what it might look like. You just create a new JSON object. There could be a tree. Here it's only ship name and mission name in it. And then you just say scope.games. We defined scope.games on the previous slide. You just say add this new JSON object to it, and boom, it's saved in the database, and everybody else gets updated. So this was pretty darn cool. I thought I would spend a lot more time building this part of the game than I actually did. That was the first lesson. Now this looks great, but we're building a game here. Is this fast enough? So I've pulled out my trusty Chrome dev tools, and Chrome, has anybody here used Chrome dev tools built into Chrome? Oh yeah, good. If you haven't, check them out. It's built into Chrome if you have it. So I wanted to measure how quickly do we get these updates, do the other players get the updates from Firebase. So is Firebase fast enough? Yeah. So in my game, with my code and my amount of data, it took 17 milliseconds to assemble all the data on the client. I sent it off to the server. It took 28 milliseconds to send it and wait until the first byte came back. And then it came back in dribs and drabs over the next 41 milliseconds. So this was a measurement I did recently in my house. So in Martin's house, end-to-end latency is 86 milliseconds. Now, is this fast enough for a regular business app? So if user A updates, say, approves an expense report. Let's say it's an expense report app. If user A approves an expense report, and 86 milliseconds later, user B sees in his UI that it's been approved. Is it fast enough? Not fast enough? What do you think? Fast enough? Yes. Yes, definitely. Because in most cases, you would have the user B would have to reload the page, and that could be minutes or hours later. But here, it pops up in the UI. All right, harder question this time, okay? Thinking caps on. Is this fast enough for a turn-based game? Let's say you built tic-tac-toe using Firebase. Player A makes a move. 86 milliseconds later, that move shows up on player B's machine. 86 milliseconds, fast enough? Yes. This is, like we saw before when we created a new game in that table, it's really hard to even notice that it's not simultaneous. Now comes the hardest question of all. Is this enough for a real-time game that shows 60 frames per second of animation? Well, it took some work, but it can be done. It just turns out that real-time 60 frames per second multiplayer games are hard to do. Firebase helps a lot, but we have to do special tricks. And one of the things we ran into was this, choppiness for player 2. So here we have player 1 gets a nice, smooth animation. Spaceship moves across the screen. And then when data is synced, that's the red arrow, the player 2's display is updated. And it looks extremely choppy for player 2. Because what's going on is this. Player 1 gets a smooth 60 frames per second animation. Player 2, he only gets updated maybe every 0.2 seconds or something like that, which creates extreme choppiness. By the way, this would not affect any business apps. It's only if you do real-time game and you want to show 60 frames per second animation. So, how do we get around this? Any thoughts? Pardon? Interpolate? Yep. Because we know what course and speed the spaceship is on. So we can do this. We can update the local game state 60 times per second on player 2's machine. And then when data comes over the network, we just throw away whatever data player 2 has and replaces it with the data that came over the network. So this is something that game developers invented back in the 90s. And fortunately, I found a book and a blog post where this was described, and we implemented it for our game. And when you do that, you basically decouple animation from the data updates, and it looks great for both player 1 and player 2. Now, what happened next was really interesting. We thought all problems were solved at this point. But you know, you're engineers, I'm an engineer. You know that a lot of engineering is this. It's an iterative process. You want to build a piece of software, and you run into this giant problem, like the choppiness for player 2. You fix it, and only then do you see this slightly smaller problem, but still pretty big, that was hiding behind problem number 1. And this problem number 2 was not visible before, and you fix it. And then what happens? Problem number 3 hides behind problem number 2. And then you just keep on fixing new problems as you discover them, until at one point you're just like, I can't be bothered to fix that new problem, and ship it. And out goes the software. So the next problem we found was really interesting. It's this. Let's say we have a souped-up gaming PC. Here, player 1 has that. And let's say player 2 has an old phone from 4 years ago. And then the spaceship moves far slower on the slow device. And then when data is synced over from the fast to the slow device, the spaceship position jumps. Looks terrible. Fortunately, game developers back in the 90s figured this one out. So here's what's going on. The player 2 gets the machine. Player 2's machine can't update as fast as player 1, so more infrequent updates. But the key to what's going on here is it says update local game state and display. We have actually two things going on there on player 2's machine. And when you look at the timing here, you see that updating the game state takes less than a millisecond, 0.17 milliseconds. And you see that the vast majority of time is actually spent drawing the pretty UI. So even the slowest machine, even if that old phone that nobody uses, that 5-year-old device you have in a drawer somewhere, can easily run game updates 60 times a second. So this is what you do for slow devices. You run update game state 60 times a second for the slow device, and then you draw the user interface whenever there's time to do it. And we will skip through some code here real quick to go on to the next. I'll talk a little bit about the code. Here's a naive implementation. This is how people built PC games in the 80s. And you may have had the fun experience of running a PC game from the 80s in a PC emulator, and it runs way too fast. Because it's an infinite loop. If you have a fast machine, this will run super fast. So in JavaScript on modern browsers, you have a call called request animation frame, where you say, please call my code, my main loop every now and then, and tell me what the timestamp is. And then you do some fancy footwork there, where you basically calculate how long did the last render call take? How long did it take to draw the UI last time? And you run update simulation 1 or more times so that it keeps running. And then everything is good after that. And with a fast device, you get a prettier animation. With a slow device, it's not quite as pretty, but at least the game plays at the same speed on both devices. The last lesson was a really profound one, and it made me think back to a book I read in the 90s that I think any software developer should read, and it's this, Computers as Theater. So this was written in the 90s, and they've since come out with a new edition of it, and I don't know what I think about the cover of the new edition. I prefer the old one I have in my bookshelf. But the main point that Brenda Laurel makes in the book, and it's an excellent book, she takes lessons learned from theater, on-stage theater, and applies those principles to building user interfaces for computers. And the main point I took away from this was, if it can't be seen on screen, it doesn't exist, as far as users are concerned. So the corollary to that is, if it's significant, if there's an entity or a process in your software that is significant, you need to show it on screen. And you will forget about this over and over again, because you wrote the code. I wrote the code as well. We have all written the code, so we know what's happening. We have a very strong mental model of what's happening in the software. But the poor user only has the user interface to look at, to guess from, when they're building their mental model. So I'll show you an example, and this was a mistake I made in the game, and I'm now working on fixing it. I had here before, this is the engineer's view. There's a main reactor, an auxiliary reactor, and down there on the left, there's fuel. So reactors are important. It's good they're on screen. Fuel is important. It's good it's on screen. But my playtesters were confused about how do reactors use fuel, and how does that hang together? And fuel consumption is not on screen. So we'll see if this works here. So this is a prototype I'm working on now, where fuel consumption is actually shown on screen. So when the user here pulls up the power, you see the little fuel pump thing start spinning. It fills up with this sort of yellow fuel-like liquid and spins. And the more power the user puts on a reactor, the faster that wheel spins. And when you pull it all the way down to 0, the wheel stops. So I still haven't tested it with playtesters, but I think it's something for all of us to remember when we build software. If an entity or a process is important, it needs to be on screen. And always difficult to move on from a video slide. Okay, so Firebase, I showed the real-time database stuff. It has all these other functions, more than you can shake a stick at. For example, you can have it reconfigure your app, make changes in your mobile app without having to deploy a new version. You can get crash reporting for all the crashes happening in the field. You can put ads in. You can do all these things, and I encourage you to look at them. But that was it. So games need to be fast, shared, and user-friendly. But we're increasing, and I showed you somehow with Firebase, apps can be fast because they always have the real-time data. You don't have to wait for it. They can be shared because with Firebase, data is synced across clients. And user-friendly because you always have the latest data. You don't need to make a call to a server, an AJAX call or some other call. You always have the latest data in your JavaScript or in your Android app or in your iOS app. And these lessons are great for games, but where games are today is where other software is going tomorrow. And with that, it is time for questions. And while you're asking questions, while some of you are asking questions, the rest of you are going to bit.ly/mgamedev because you're going to fill out a 4-question survey about this talk. I really appreciate the input. And I have some Android, some Google Play gift cards to give out as prizes. So while I see people have started pulling up, we're going to do a drawing in 5 minutes. In 5 minutes, we'll do the drawing. 5 minutes for questions. Any questions while the rest of you are filling out the survey? Yes? I believe it will be shared from the conference, DevFest. I believe so. Yes?
Can Firebase take, say you have existing JSON documents and shove it in without conversion into new format? Can you take a pre-existing JSON document?
So the question was, can you take an existing JSON document and shove it into Firebase? I believe so. I've done it for some JSON. I don't know enough about JSON formatting. It's worked for the ones I tried it on. So I guess I had to parse it, or call what's it called again? The opposite of stringify on it to make it into a data structure, and then send that object across. So it was 2 lines of code. Would you ever use Firebase for full text search? Was that the question? Yep. No, not for full text search. I wouldn't. I would use this for stuff that updates frequently. For example, last weekend I was in DevFest Chicago, and they had built their conference app that showed all the sessions at the conference was on Firebase. So, for example, if they needed to swap rooms for 2 sessions, they could just update it in Firebase, and boom, within 86 milliseconds, anybody who looked at it in the app saw the updated data. So business data like that changes often. But there are other products in the Google Cloud Platform that does full text search and that focus just on that. So check that out in Google Cloud Platform. Cool. Any other questions? Or should we start looking and see and do the drawing? Yeah.
I'm kind of curious, my comment to you was improving the talk, just let the audience play the game.
Yeah, that's good. Yeah.
Is there any limitation because it's something in the cloud, and what would be the wrinkles to let 5 people here?
Yeah. See, right. So I've been thinking of that. I don't know how to put multiple. We'd have to have a setup where we can put multiple, project from multiple machines up here. And here I'm only able to project from one machine at a time. So you have to suffer through my terrible video playing skills, I'm afraid. Sorry about that. Yeah. Ooh, scalability. Ooh, that's a good question. I know that a year ago I attended a Firebase talk with the folks in the Firebase team who know more than I do about this. They said that at any given point they have about 1 million clients hooked up and so, with open connections. So I have 5 players, so even if I run many tens of thousands of games at the same time, I wouldn't even make a dent in that 1 million they have going at any time. But ask Frank van Puffelen, ask anybody of the Googlers who have the Firebase shirt on. I have a Firebase shirt under here, but I was so cold I needed a shirt on top. Yeah.
I've used Firebase quite heavily with a client, not web-based like you're doing. When you do web-based and a person closes the window, how long is it before the other users get informed he left the game? He doesn't send any command to the server saying I'm leaving or anything like that.
So how long does it take to, pardon?
For Firebase to realize that user has left the game so that the other players can be informed is no longer there.
Oh, right. A very good point, yeah. Because you will have clients disconnecting, and you may want to do some cleanup or for others to come in.
Client applications, usually before you leave, you can clean up yourself. That's not the same thing. Or if the
Yeah.
window closes.
Window closes, battery runs out, whatever. Yeah, so I see that happen in the game all the time, and I have defined a trigger for that, and sometimes it takes up to 5 or 6 seconds for Firebase to realize that this person disappeared, if my code wasn't able to run the cleanup. So that code, you can define, so with the cleanup, when a client leaves, you can say, whenever a client leaves, update this data in the database, and then the server does it. And it may take up to 5 or 6 seconds before the server realizes. One more question, and then we'll do a drawing. I think we had one here. Is there any server-side data validation? It's a top feature request. I kid you not, every single Firebase talk I give, I get that question.
You see the problem, right? Like if I was a malicious player of your game, I could just pause it in my current...
Yeah, you can do... Yeah, so the question is, a malicious player could send the wrong data and so on. Yeah, there's some validation rules you can put in JSON on the server, but users are asking for, so you can define a JSON file with some rules and put it up there. But the team has heard this request loud and clear. And now I think it's time for the drawing. This is my favorite part. So now we're going to look here. Is anybody? Oh my gosh, this is a lot of people. Love it. So what's fun with this is that I get a lot of people fill out the survey, and usually I get something like 80 or 90% survey completion ratio. Once in New York, I got 106% survey completion ratio. Oops, no, that's not what we wanted to do. This is the wrong, sorry, I clicked the wrong button. This is just the test users. I hope we don't have an Emma here. Yay for Emma. I wanted to click this button. Yes. So there were 95 unique entries. I can only display up to 48 on the wheel, otherwise it becomes you can't read it. But here we go. So this, you may not know this, but this is driven on brand new Google technology called the Drumroll. So you need to take your hands and do like this, drum roll, and when I hear enough drum roll, I will spin. Yes, come on, drum roll. Yeah. We'll see the first $25 gift card goes to Tony, no, Kenneth, Ma, Vu, Agnes, Brian, Mason? Mason! Come on up, claim your prize. And then we have to be fair, so we'll remove Mason. You can only win one. Thank you for filling out the survey, Mason. All right. Second and last $25 Google card. I think we need a bigger drum roll this time. Okay, ready? Drum roll! Yeah, here we go. Last card. Agnes again? No. Kumar? Charles? RD? No? Jen? Akshay! Akshay? There we are! Yeah! Thank you very much for filling out the survey, Akshay. So thank you for your attention. I'll be out there if you want to talk more game development or geek out about game development or Firebase. And have a great rest of the DevFest. Thank you.